Good afternoon. Are we already in the afternoon? Yeah, we're in the afternoon. Uh, Welcome back once again to Microbiotics BioTalk. Uh, Sorry for the long break. We're trying to get better communication devices so that we'll be able to produce quality BioTalks. And in the process, we've actually lagged behind on a lot of things. So we're sorry for that long breaking transmission, in quotes, and we'll try and improve on it. So let me welcome you back with this topic, introduction to inflammation, and we'll be talking about, we'll be introducing ourselves to acute and chronic inflammation in this BioTalk series. So let's go. So now inflammation is part of the defense system of every, should I call it, every higher animal, especially let's use human, and it's an innate defense mechanism, and it's usually the first defense mechanism being mounted against any harmful or foreign I call it objects or microorganism that comes into the body. So, and it's non-specific. It's non-specific in the sense that it doesn't actually recognizes or try to separate any of these pathogens or harmful objects that comes into the body, harmful entity that comes into the body. All it does is once something comes into the body that it deems harmful or foreign, it mounts a lot of arrays of immune constituents against these bodies, against these objects, and then try to clear it out of the body, and also starts the healing process. So, and all of us have felt inflammation with in fact, that's even one of the most common, if not the most common, immune defense mechanism that we always feel, we usually feel in our body. And by the time you check, if you look at the 5 fundamental signs of inflammation, you check a part of your body, you see that it is hot, it is red, it's swelling, it's painful, and perhaps it's not even functioning the way it's supposed to function. That means that that place is highly inflamed. In fact, the most common type of inflammation that we usually feel all over our body is what we call fever. It's where the body tries to raise its own temperature in a way to get rid of the external infectious or non-infectious agents. So that's majorly the signs of inflammation, and those are the signs of inflammation, and that's what you expect. For instance, if you prick your body, if something just, let's say a thorn, or maybe something is, something like maybe a nail gets into the body, and eventually after you remove it, after a while, you feel all these signs. You feel the place is hot, you feel it's red, it's going to change in coloration, then probably the swelling, and that swelling eventually by the time we check it's usually filled with pus, and then it's, of course, definitely is going to be painful, and then the area will actually experience some loss of function if it's something that you're very observant, if something that you can definitely observe. So let's quickly get down to the types that we have based on the period, how extensive it is, and based on the processes that respond to the injury cause. We have what we call acute inflammation, which occurs immediately after injury. In fact, this one takes basically within hours. You start feeling all the symptoms of inflammation. That's acute. It's usually immediate, and usually it lasts for a few days. If you're able to get rid of the injurious substance, It will last for a few days. The pain, the swelling, and everything will come down after a few days. We now have what we call chronic inflammation. This one, it's when the acute inflammation refuses to stop, and it lasts for months and years. It's a continuous one, like the word says, chronic. So that means it goes on for a long time. And then we have one that it's not really a classification, but we need to recognize is that the subacute phase. That subacute phase is the period between when an acute inflammation becomes a chronic inflammation, and it lasts for 2 or 3 weeks. So it's not usually, it's more or less like a phase. It's more or less like a phase. When an acute inflammation is supposed to resolve itself and it doesn't resolve itself, the period between transitioning between that acute phase and a chronic phase is what we call subacute inflammation. So, okay, like I've already explained, these are the should I call it the better explanation to this. So we have acute inflammation start after a specific injury, which will cause soluble mediator like cytokines and the rest to promote the migration of neutrophils and macrophages to the area of inflammation. So let me quickly explain this. Once the body experiences an injury, there are some mediators, there are some chemicals, and which refer to as cytokines and chemokines, that would activate some specific cells in the body to migrate to those areas. So those specific cells are usually neutrophils and macrophages. They move to this area. So in anticipation of maybe there's an infectious agent, or in anticipation that this particular object, this foreign object that comes into the body, these foreign entities that comes into the body can be harmful. So they are like the infantries of immune system. They migrate to that area and try and block it and wall it off. They surround the area and then they release chemicals. They release all their potent weapons in the bid to clear off that area and start the healing process. In fact, that one of these component is even the clotting factor. You know, when you have an injury and you start bleeding, after a while you realize that the blood starts clotting. It's part of the immune system. It's part of the process that all this component of the immune system starts in order to stop the harm that is being done to the body. And the macrophages are more or less like a cell that swallows. They ingest all the harmful substances and try to break it down. The neutrophils synthesizes some chemicals and try to kill any invading microorganisms or pathogens. So, and it has a limit. It has a period. If all this process exceed 6 weeks, then that means that there is likelihood of this acute inflammation to proceed from subacute to chronic one. Any inflammation that doesn't resolve after 6 weeks is already becoming chronic. And when it gets to the chronic stage, we have more specific and advanced component of the immune system being mobilized to the point of injury, to the point of entrance of these pathogenic or harmful substances. Some of these are T lymphocyte cells and the plasma cells. And eventually, between that subacute phase to the chronic phase, if the inflammation still persists with no recovery, then we now get into this tissue damage and fibrosis. And then all sorts of other cells will start coming around, and that area will become a real site of war between the invading external foreign objects and the resident immune system component. So let's quickly look at acute inflammation. Like we've already said, it's an adaptive, it's an immediate we call it adaptive in a way because it's in it, but in a way it's adaptive because it's almost like after a while, the new component that are coming over to that place are already known. They know what they are supposed to do, though they have limited specificity, and they try and attack any infectious agent or harmful agent that comes in, and in a way, they also respond to even tissue damage. When tissue itself gets damaged in a way, they migrate there and they try to control this damage by maybe walling off the damaged cells and ingesting them. Now, the controlled inflammatory response is very beneficial, of course, and it provides protection against infectious agents, including maybe bacteria, protozoa, fungi, and even viruses. And the goal of inflammatory process generally is to restore homeostasis regardless of the cause. And the meaning of this is that all the responses, the immune responses being mobilized, is to restore that particular environment back to the way it was before. That's the meaning of that. That's what this inflammation response of immune cell is all about. They are trying to limit the damage, and then after they've done their part, they restore the cell, the tissue, or even the organ back to its original state, so that the function and the structure will be maintained. But unfortunately, if it is not regulated, it can become detrimental. Let me give you an example of this. I'm going to use COVID as an example. One of the first identified causes of pathology in COVID is the fact that the virus simulates what we call cytokines. The moment the virus gets into the body, the immune system mobilizes some innate immune response against it, stimulating cytokines. Now, if you remember what I said at the beginning of this talk, I said cytokines are chemicals that signals other powerful immune cells to come over there and try and fight. So now the continuous stimulation of cytokines is usually referred to what we call cytokine storm. That's the first, in fact, I think that is the first thing being discovered about COVID-19. The cytokine storm, the continuous increased and the continuous production of cytokines. So the more this thing are being mobilized, the more the immune cell keeps coming around in droves, in large numbers, and attacking what they believe are the infectious cell of the lungs, of the area that they believe the virus is hiding. So it's a form of immunopathology, which means the immune system is attacking the body of the host, the body of the person is supposed to protect, in order to clear the invading pathogens that is attacking the body. So that's that's an example of when inflammation can become extremely detrimental, and instead of it to actually do the work it's supposed to do, it becomes harmful to the person it's supposed to protect. So these are the causes of acute inflammation, and they are definitely classified into two groups, to two types of inducers, where we call the exogenous and the endogenous inducer. Like the name implies, the exogenous inducer means they are coming from outside. Exo, that's from outside, and the endogenous means that it's within the system, within itself. So, like we can see, the endogenous inducers include microbial inducers, which are the what we call the pathogen-associated molecular patterns, AMPs. These pumps are usually on every living organisms that comes into the body. There's some particular patterns on the body of this organism that the immune system can recognize as a foreign entrance, a foreign body coming inside the host body. So once they recognize these patterns, they attack it. It induces that particular response. And then we have virulence factor, which are very specific to pathogens, specific to pathogenic organisms like viruses. So once these ones get in contact with the cells of the body, with the immune cells, they believe they are outsiders, and then they try to attack them. Then we now have non-microbial inducers. The first one I mentioned are microbial inducers. This one are non-microbial inducers, and they causes almost the same responses. They are allergens, like dust, pollen, toxic compound, irritants, maybe even skin irritants, anything that is non-microbial in nature but also induces inflammation. They are more or less called microbial inducers, and those are the examples that I've mentioned. Then the endogenous inducers are different. The endogenous inducers, how can I explain it? Okay, let me break it down this way. In the body, we have a process we refer to as apoptosis. Apoptosis, that's what we call a programmed cell death. All the cells in our body, maybe with the exception of the brain cells, they have a lifespan. They have a period in which they can exist. They don't usually, it's not as if they will exist for long. They are being continuously replaced. When they get old, they die, then they are replaced. In some instances, they are not actually being killed by themselves, but maybe they are infected by a particular organism, especially viruses. So when viruses invade a particular cell, the immune system recognizes that body as a foreign body. The moment they start displaying some factors on the body of that cells that will tell the immune system that this cell is under invasion, that this cell is not like other cells anymore. So and because of this, maybe when a particular cell dies, or maybe it's infected by a virus, for instance, there's a signal, or there are signals that come from them. There are signals that come from them. Maybe it can be displayed on the outermost part of the cell, or they are exhibiting they are emitting some chemicals. So the moment the immune system sees this, maybe they get this signal, or maybe they are malfunctioning, like a cancerous cell. The moment all these things are happening, the immune system recognizes that as something to be cleared from the system. They recognize those affected cells or tissues by something to be cleared from the system, and then they get induced, and then they start the process of inflammation. So if you have a dead cell, a damaged cell, an infected cell, or tissues inside the body, they are also a form of inducer that can cause inflammation. We also have another way we can classify inflammatory inducers. You have the infectious ones, infectious factor like the ones I mentioned the other time, the bacteria, the viruses, fungi, and the rest. Then we have the non-infectious ones, which are listed here as maybe they can be due to physical injury, like a frostbite, burns, physical injury, foreign bodies, those kind of what they call it, those kind of chemicals. Then we now also have what we call biological inducers, and then and this is extremely very funny. We have physiological inducers as well. If you can see there, they said due to excitement. I think I will have to come back to this one and give you, of course, when there are some chemicals being released in the body due to excitement, over excitement, maybe when somebody is high. Well, we'll talk about that later. Don't let me go to that area because it's actually a very sensitive area. So let's quickly focus on chronic inflammation. Now, chronic inflammation is it's one of the most devastating form of pathological illness that one can have, and it's a slow, long-term inflammation that can last for years. In fact, a lot of us are not seeing it. It's, as you can see from the data being given by the World Health Organization, they said chronic inflammatory diseases are the most significant cause of death in the whole world. And it's unfortunate, but it's the category of this disease we have them around us a lot. We can see the ones that are given here: diabetes, obesity, cancer, stroke, heart disorder, that's cardiovascular issues, chronic respiratory diseases, yes, like COVID. All these are due to chronic inflammation. And the extent and effect of chronic inflammation varies with the cause of injury and the ability of the body to repair and overcome the damage. So we'll be talking more about that. These are the causes. Now, causes of inflammation, we have different causes, and after this talk, I'm still going to prepare a talk that focuses majorly on chronic inflammation because we need to talk about it. But let me just quickly mention this so that by the time we want to do the next BioTalk, I'll be able to focus on chronic inflammation. So one of the causes is failure of eliminating the agents causing acute inflammation, exposure to low level of a particular irritant or foreign material that cannot be eliminated also. Then we have what we refer to as autoimmune disorder. This one is funny. Your immune system recognizes, instead of recognizing the body is supposed to protect as part of itself, it's recognizing it as a foreign antigen and it keeps attacking it. So then we have a defect in the cell responsible for mediation of inflammation. There are some cells that are supposed to control how inflammation is being induced, how it's being induced, how it's being restricted. But once these cells are defective, then there are issues. Then we have recurrent episodes of acute inflammation. When acute inflammation keeps happening over and over and over and over again, then it becomes chronic. And lastly, we have inflammatory and biochemical inducers that cause oxidative stress and mitochondrial dysfunction. We're going to talk more about that in the next BioTalk, where I will be focusing majorly on chronic inflammation. As said here, next topic, we'll be talking more on this. Thanks for listening. Stay ready, and I promise that our next BioTalk we will not actually take this long in coming up. See you and stay healthy. Thank you.